Hello everyone, my name is Villanueva. I'm a second-year PhD student in the Physics group at UPF, and in this presentation I will be discussing the computational modeling study on the hemodynamic changes that occur in the fetal circulation post-connection to an artificial placenta. Extremely preterm birth, that is defined as birth before 28 weeks, is a major cause of perinatal mortality. To improve their survival, Barcelona Natal aims to create an artificial placenta that involves surgically removing the fetus from the uterus and connecting its umbilical cord to an oxygenator using PVC tubes. Experiments were performed with 4 110-day lamb fetuses that approximately correspond to 23-week human fetuses, and their blood flows and pressures were measured in the umbilical artery pre- and post-connection to the lower impedance artificial placenta. Hemodynamic changes were observed. The blood velocity pattern changed from an exponential decay to a flat diastolic flow with a secondary peak. Also, there was a decrease in pulsatility index and an increase in pressure and heart rate. Therefore, we aim to reproduce all of these changes using 0D computational models, since they can accurately simulate global hemodynamics in the circulation to investigate whether they are produced due to differences in placental impedances and the presence of wave reflections. The closed 0D model from Penati et al. Was used to simulate the fetal cardiovascular system. It represents organs and vessels by distinct compartments that are characterized by a set of ordinary differential equations relating blood flows and pressures. Since the artificial placenta presents a lower impedance than the biological placenta, a parametric analysis was performed by reducing the compliance and the resistance of the placenta and increasing the fetus's heart rate. The results that most resemble the in vivo experiments showed a decrease in pulsatility index with respect to pre-connection, but the pressure was lower and thus unrealistic. For this reason, a simple wave reflection model was added, considering two possible origins, the umbilical artery with PVC tube and the PVC tube with the oxygenator interfaces. A parametric analysis was again performed both for the time delay, which is the phase shift between the forward and backward waves, and the reflection coefficient that depends on the pulse wave velocity between both media. The results showed that only when adding wave reflections, similar patterns to the in vivo experiments with a flat diastolic flow were obtained. Thus, it can be concluded that hemodynamic changes may be produced by the lower resistance and compliance of the artificial placenta, and also the presence of wave reflections caused by the impedance mismatch between its components.